know much about algebra. Don't know what a slide rule is for. But I do know what it was to. This was to be with you. What a wonderful world this would be.
Welcome back, everybody, to Mr. K's 30 Minutes of Math. Good to see everybody. It was a beautiful day today. I hope you got a little bit of time outside. Well, happy Tuesday, and I'm excited to dive right in, so let's do it. Let's start with our riddle. Let me turn the video off here 1 second. All right, and as you recall, this was our riddle from yesterday, and we had these three math equations, and they didn't actually make sense because we know that 12 times 12 is not equal to 9. In fact, 12 times 12 is 144. By the way, maybe you remember 12 times 12 is the same as 12 squared, which means 12 times 12. All right, well, that's one bit of information. Let's see. Then we have 23 times 23. That is most definitely not 16. So we'd have to think a little bit more about what that is doing with the number 16. Well, let's figure out what 23 by 23 is. So let's work that out right here. 3 ones times 3 ones gives us 9 ones. 3 ones times 2 tens gives us 6 tens. And then we have 2 tens times 3 ones is going to give us 6 tens, or 60. And then 2 tens times 2 tens is going to give us 4 hundreds. So that would be 9. One more 100 there. 529. All right. Well, we know that's 529. Does anybody see a relationship between 9 and 144 and 16 and 529? Go ahead, take a second and think about that. Let me give you some Jeopardy music, see if you can figure it out. Okay, welcome back. Let's see, Ezra writes, and if you add the numbers up, you get 9 and 16. Well done. Very nice. So, if I got my sound machine back, if you add up 1, 4, and 4, you get 9. Similarly, if you add up 5 and 2, that's 7, plus 9 more, that gives you 16. So what should go where the question mark is? 34 times 34. Why don't you go ahead, take a second to figure it out and let me know what you get. Let me give you a little bit of music. Whoops. Get some music on stuck for a second. Okay, I see some folks writing in. Let's check it out. 34 times 34. All right, 4 ones times 4 ones is 16, and we have 6 ones and a 10 I'm going to put up there. 4 times 3 tens will give us 12 tens, or 120, plus 1 more 10, which would give us 130. Then 3 tens times 4 ones would give us 120. So, and so I'm going to do that. And then I have that. And we wind up with that. And if you add all that up, 1 plus 1 is 2, plus 7, I'm sorry, plus 5 is 7, plus 6 is 13. Well done, well done. So that was a pretty good one. You could try it out on friends or family and see if they can figure it out. All right, let's dive into our homework from last night. We had this crazy looking problem, which was 1,000,001, 1,000,000. So I'm going to write it like this. It might be a little bit easier to see. Okay, so 1,000,001 1,000,000ths minus 1/1,000,000th. All right, so 1,000,001 1/1,000,000ths is really, really close to just plain old 1. And 1/1,000,000th is really, really close to 0. 1 minus 0 equals 1. And if you'll notice, we can do the exact problem as well. 1,000,001 1/1,000,000ths minus one of those would just be 1,000,000 1/1,000,000ths, which is 1. Well done, guys. Well done. It looks like everybody got that. Fantastic. All right, let's go on. I want you to try this one. I'll give you a little bit more music. Okay, I see we have some disagreement about this one, which is wonderful. Let's take a look and see how it would go. All right, let's estimate first. 6/7, well, that's almost 7/7, which would be 1 whole. 1/14, well, that's almost 0/14, so that would be 0, rounded. 19/21, that's pretty close to 21/21, so let's call that 1 when we round it. And then 1/7, that's very close to 0/7. So we'd have 1 plus 0 is 1, minus 1, which is 0, plus 0 is 0. So our estimate is 0. All right, let's remember that. I'll put it in a box over here. Now let's do our exact work. We have 7ths, 14ths, 21sts, and 7ths. So let's decompose everything into 21sts. All right, 6/7 is how many 21sts? Well, we can decompose the 7ths by multiplying by 3. So we're going to multiply our numerator by 3. So 18/21, that's that one. Then 1/14. All right. This one is tricky. what do we multiply 14 by to get 21? Well, actually, it's 1.5, 1.5, because half of 14 is 7. So we'd have 14 and 7 is 21. So we'd have to multiply this by 1.5. So we'd have 1.5 or 1.5 21sts. That one was a little bit tricky. All right, then we have 19 21st. We don't need to do anything with that. And then 1/7 is decomposed into 21sts by multiplying by 3. And so that would give us 3 21sts. All right, so let's do it now. We would have 18 21sts, 1.5 21sts, 19 21sts, and 3 21sts. Let's add that. I'll add it up down here. 18 plus 1.5 or 1.5 minus 19 plus 3. All right, so 18 and 1.5 or 1.5 would be 19.5. That takes care of this. Minus 19. Well, if we have 19.5 and we take 19 away, we would have 0.5, which is the same as 1/2. So that takes care of that. And then we have 3 more. So our answer is 3.5. Very, very interesting that we got a very different answer. Just checking in with everybody, see how we're doing. All right, fantastic. Let us move on to one more. Go ahead and check this one out. Okay, welcome back, everybody. Let's take a look at this one. 6/3. 6/3. Let's start with that one. 6/3. Wait a second. We know what 6/3 is because we're going to do our number bonds. 3/3 is 1 whole, and another 3/3 would be another whole. So let's get rid of that. We know that 6/3 is 2 wholes. All right. 8/4. Similar, 4/4 and 4/4. So we have 2 more wholes. All right, let's put that down. Then 11/12. That's really close to 12/12, which would be 1. And then 12/4. Time for those number bonds again. 4/4, and then another 4/4, that's 8. And then 4 more, that's 12/4. So we have 1, 2, 3 wholes. So we can make this one 3 wholes. So we have 2 plus 2, which is 4, minus 1, which is 3, minus 3 is 0. So that's our estimate. So let me write that up here. Estimate 0. All right, now let's do this one exactly. Let's see what we've got. Well, we can go back. This is still 2 exactly, and this is still 2 exactly. We have this is 3 exactly. The question is, what do we do with the minus 11/12? Well, here's what I'm going to do. I'm going to actually turn this 3 into 12ths. So here's what we do. We take our 12/4 and we're going to decompose it into 12ths by multiplying by 3, which gives me 36/12. All right, so let's use that. Minus 11/12 minus 36/12. Okay, so 2 plus 2 is 4 minus 11/12 and minus 36/12. Well, if we take away 11 and 36, that's like saying we're taking away 47/12. Let's do some number bonds on that. 12/12, that's 1 whole. 12 more, that's another whole. 12 more, that's another whole. That takes us to 36. And 11 more would take us to 47. So we have 4 minus 1, 2, 3 wholes, and 11/12. Well, if we have 4 wholes and we take away 3, then we'd have 1 whole. We still have to take away 11/12. Well, we know 1 is the same as 12/12. And so there you have it. 1/12 would be our exact answer. Well done. I see a couple of folks got it. Fantastic. I am very, very proud. That was a tough one. All right, let's get to our joke of the day. Northeast, not like hanging out with the squirrel from the southwest. And you have to think about the coordinate plane we've been discussing. Remember this thing? To come up with the answer. All right, go ahead, take a second. Let me do our Jeopardy music again to give you about 30 seconds to think it over. Okay, we got some cool answers. They don't add up. They were opposites. It's negative maybe. Let's see. Because the squirrel from the southwest was always so negative. Very good. We had a couple of folks who came up with that, but I also like opposites. That works too. Let me do a little bit of explaining in case anyone didn't quite follow that one, and that is no problem. When we look at the coordinate plane, remember we've been talking about this. Here's our x-axis, and here's our y-axis. You can think about this in terms of directions: north, south, east, and west. So the area over here would be northeast, and the area down here would be southwest. And if you remember, everything down here in southwest is going to be negative because any point over here is negative. The ways, excuse me, talk about these different sections. Sometimes we use directions, but also we call these quadrants. Quadrants. Anybody know what does the root quad stand for? Quad. Anybody know? Think of quadrilateral. Little Tang writes in 4. That's right. 4, because there's 4 sections. We call this quadrant 1. We use Roman numerals. Quadrant 2 is over here. Quadrant 3 is over here. And quadrant 4 is over here. Remember, the V in Roman numerals is 5, the I is 1, and when the I comes before the V, we subtract it. So 1, 2, 3, and 4. So here's my question for you all. Which quadrant would this number be in? -2, 3. So -2 on the x-axis, and then regular +3 on the y-axis. What quadrant would that be in? Let's see what folks say. And we have folks writing in 2. Very good, because we would go 2 to the left. That's our -2. And then 1, 2, 3 up. So it would be right there. How about 1, -6? 1, -6. Where would that be? 1, -6. Go ahead and give a try to that one. Would that be quadrant 1, 2, 3, or 4? And folks are writing in to say 4. Little Tank is writing enthusiastically that it's 4. Let's take a look. Well, 1 on our x-axis, and then -6. So we go down 6. 1, 2, 3, 4, 5, 6, right there. So yes, we would be in quadrant 4. Okay, I'd like to teach you something new about our coordinate plane. We're getting a little bit into algebra, which is kind of fun. So let me erase all this stuff so we can try something new out. All right, so let me start by asking you all. Oh, I'm going to use my cool ruler. I just learned how to use this. I'm going to turn it to 45 degrees. And I can draw a line using the ruler. So it's perfect. Let's see. Look at that. All right. And then I'll take the ruler off. Okay. And it's a line, and lines go on forever. So I'm going to put arrows on each end. That means it goes on forever. I appreciate that, folks. Like my ruler. All right. Now, here's my question. I'm going to put 2 points on the line. Let's call this one A, and let's call this one B. My first question is, what are the coordinates for A and B? What are the coordinates for A, and what are the coordinates for B? Go ahead and take a second and think about that. Ezra writes in, Delilah writes in. All right, A, very good, is 2, 2, because we go 2 across on the x-axis and then 2 up on the y-axis. And then B, folks are writing in -4, -4. Let's check that out. All right. Well, we're 1, 2, 3, -4 on the x-axis, and then 1, 2, 3, 4 down. Very good. -4 on the y-axis. All right, very good. Now, here's the interesting part. This line has what's called a slope. Slope. Slope is how steep the line is. How steep the line is. So here's, I'm just going to draw another one. This is a line with a steep slope. That's a little bit less, a little bit less. And this is a pretty shallow slope. So the question is, how do we define the slope of the line? And we do that by picking 2 points and figuring out what the change is in the y-axis and in the x-axis. So let me explain. And there's a simple way of remembering that, which is, by the way, this little triangle means change. Rise, how much it rises, over how much it runs, meaning how much it goes up or down versus how much it goes across. So here we go. I'm going to show you this one. Let me take that away. Let's start at B. How much does it rise to get to A? Or the change in the y-axis, the up and down. So here we go. 1, 2, 3, 4, 5, 6. That's its rise. And then its run, 1, 2, 3, 4, 5, 6, is also 6. So it rises 6 and it runs 6. 6 over 6, we know that is 1. So this line has a slope of 1. All right, now I know that was a lot to absorb. I'm going to come back to that tomorrow because we're getting into some super cool geometry and algebra, and I hope you guys are enjoying some of this new math that we are doing. I do want to close out a few more fractions problems before we finish the day, so I am going to move to these. Now, to be clear, these we're only estimating to the nearest half because there are some really crazy numbers here. All I want you to do is estimate to the nearest half. Go ahead and take a second to do these. Okay, welcome back, everybody. Let's take a look at these. First, we have 5/33. 5/33. My question is that closer to 0/33 or 33/33? I think we can agree that it is closer to 0/33, so I'm going to put a 0 up there. For some reason, it doesn't seem to be showing my writing. So hold on one second. I'm going to stop the share and then do it again. I'll be right back. Let's see if we can make that work again for you guys. I'm sorry about that. Let's see. 1 second. All right. And voila. I think we're better now. Okay, that's better. All right. Now, so 5/33 would be maybe over here. All right, next we have 82/95. Well, is that closer to 0 or to 95? Definitely closer to 95, maybe right there. So we're going to call this one closer to 1 whole. Then 1/19, definitely over here, closer to 0. And then 26/51. That seems like it would be kind of right here, which is almost 1/2. So our estimate would be 0 plus 1 plus 0 plus 1/2, and that would give us 1/2. All right, well done. We had a few folks come up with that. Very good, very good. I'm going to give you one for homework, and then we'll go to the riddle. Here it is. Write it down or take a screenshot. I know it's a long one, but all you're going to do is estimate. to the nearest half. I'm not asking you to calculate it exactly. It's just to estimate. All right. Go ahead, write it down. Take a screenshot, take a picture. I know it looks kind of crazy, but all you got to do is estimate. All right, here is our riddle of the day, and this is a tough one. Using only the numbers below, so 2, 3, actually, let me use this. The number 2, 3, 4, and 5, and you can use them in any order you want, and the plus sign and the equal sign. How do you make an equation that is true? You could do it any way you want. You could use the 3 first and then the equal sign and then the 5 and then the plus, whatever you want. And here's my one hint. Remember squares. Remember squares. And by squares, I mean, remember that 6 squared is 6 times 6, which equals 36. 5 squared is 5 times 5, which equals 25, and so on and so forth. Remember that as you try to solve the puzzle. All right, everybody, we are at the end of our time together today. Good luck with the riddle, and I will see you all tomorrow. Bye, everybody.